Visual Marine Salva, and this video is all about hash. So first, this file belongs to the hash example package. Think of a package like a folder that groups related Java files together. Next, we create a class called hash example. A class is just a container where we put our code, including methods in the main program. Inside this class, we define a method called polynomial hash. So this method is the heart of our program. Its job is to take a string like a word and turn it into a number we can use as an index in a hash table. So we start by choosing number 31 as our base. So why 31? Because it's a small prime number, and prime numbers help reduce patterns and collisions in hashing. Then we set hash to 0. This will be the running total that gathers all the contribution from each letter in the word. We also set the power to 1. This variable represents p raised to the power of I, where I is the character position in the word at the beginning. It's 31 to the power of 0, which equals to 1. Each time we move to the next character, we'll multiply power by 31 to make it grow. Now we loop through every character in the string. So this means if the word has 3 letters, like cat, the loop will run 3 times. For each character, we first get its numeric code. Computers store characters as numbers. For example, the letter A has the code 97, B is 98, and C is 99. Next, we multiply the character's code by the current power and add the result to the hash total. This is the polynomial hashing formula. Character value times p raised to the its position. After that, we update the power for the next character by multiplying it by 31. That way, the next letter has a bigger weight in the calculation. Once the loop is finished, we take hash modulo n. This means we divided hash by n and keep the remainder. The result is guaranteed to fit between 0 and 1, and negative 1, which makes it a perfect index for a hash table of size n. In the main method, we test our hash function using 2 words, cat and bca. We set the table size n to 10, so our indexes will range from 0 to 9. For the word cat, the total hash comes out to 114,582. When we take the number modulo 10, the result is 2, so cat maps to index 2. For the word bca, the total hash comes out to 96,384. Taking that modulo 10 gives us 4, so bca maps to index 4. Notice how even though cat and bca contains the same letters, just in different orders, their indexes are different. This shows how the polynomial hash is sensitive to character position. And that's the big idea of polynomial hash. Hashing in Java. We take each letter, give it weight using powers of a base number, add them up, and finally reduce the sum into a valid index. This is how strings can be quickly mapped to position inside the hash table.